So next one is Sumi Han. Sumi is a PhD candidate at Florida International University and the faculty at SciArc. She used to teach at AA and UCL. She has a Master of Architecture from AA and Bachelor in Architecture from Tsinghua University. Let's welcome Sumi.
Thank you, Nick. All right. Hello, everyone. I'm very honored to be here today, share my work. And I'm currently in the first year of the Doctor of Design program in FIU and just finished the first semester. And as it's almost the beginning of my research, my presentation today consists of a few previous and ongoing projects and my research proposal with a future research plan.
The next stage, the augmented age, is going to be about you and I and the way we live our life. And over the next 15 to 20 years, almost every aspect of the way we live our daily life is set to change.
So as argued by the author of this book, Brett King, we are living in the augmented age where machines and devices are getting closer to our bodies. As we are already augmented with smartphones, we are already cyborgs. And the way we can harmoniously coexist with ever-developing technology is to acknowledge that we as humans are cyborgs. We are cyborgs, augmented with devices and technologies. And I define augmentation as a human enhancement amplification by using various tools, devices, machines, and robots that are close to the human physical body and or controlled ergonomically and intuitively. And the machines that we are augmented with are not only some AR headsets, but also includes all kinds of devices, especially wearables. And in my research, I'm interested in looking at especially on the topic of exoskeleton and prosthetics. Giuliano Pinto is a paraplegic who kicked off the 2014 World Cup empowered by the robotic suit. And this historic event signaled the new era of augmented humans. The so-called exoskeleton or named wearable robots are not only helping disabled people, but are well researched for military applications since 2000. These technologies and research interests can date back to 1920s Hardiman suit, which ended up a conceptual machine. But most of the technologies could not be executed until pretty recently due to lack of supporting technologies such as material weight, computational power, and so on. But since 2000, kicked off by a huge grant in US for military-oriented research, the technology have developed exponentially since. And this led to technological development in other industries and markets, and they have been developed to help physical recovery. And then developed to help elderly and disabled, which led to the development of literal extension of bodies, requiring technologies for controlling machines with brainwave signals or muscle movements and so on. And later, the industry developed the technologies to help warehouse and construction industry to enhance the workers. And there are also types of wearables, and more recently, the researchers are looking at teleoperation to remotely control mechanical limbs. So types of wearables can return haptic feedback to bodies. Which are researched in various institutes to see if our other sensations, such as hearing or seeing, can be replaced by haptic sensation, which is really interesting. And this book is quite comprehensively lists out current available industrial and commercial wearable devices. And the marketed industry of such technology is definitely huge and growing. And from this huge range of varieties, I decided to look at mainly these types of devices in my research. And in my research, I proposed to look at two specific products. And this one, modular exoskeleton called SUTEX, is designed for construction and warehouse use, alongside with a full-body electrically powered, namely active exoskeleton robot. And I'm especially excited to imagine the kind of things we can do when empowered by such a tool. Perhaps we can draw in space with a heavy and dangerous end effector, which can be super amazing. And further to that, I'm interested in questioning how the introduction of this technology will change how we practice architecture. Just like AR technology, using either mobile devices or headsets are predictably helpful in our daily construction field, exoskeleton has been quite actively deployed in automobile factories. And more construction sites will be empowered by this technology soon. But as you can see in this video, we are still constructing ordinary buildings with such technology. And we as creative thinkers and architects should ask what kind of new spaces, architectural typologies, can be evolved by the introduction of this. And just like this stone carving glow is a great example of a wearable technology hacked by designer that brings designers and builders a new possibility. And with the use of AR glasses, designers have been quite successfully demonstrated new potentials of assemblies over the past few years. And this brings back to some of my previous work. And in this project, we, together with my colleagues, we try to answer the same question: what kind of new aesthetics can emerge from the introduction of augmented reality technology in this case? And in this project, we use AR to hack the traditional steam bending timber process. As normally, steam bending requires one-off mode, which is very unflexible and expensive. It's a heavy process. And the hacked process allowed us the flexibility in creating hundreds of different and unique curvatures. And with my research, with the interest of augmentation in general, I'm proposing to specifically look at this process deeper and test out the application of exoskeleton in this pipeline. And before even talking about introduction of exoskeleton, I'm currently ongoing project I'm going to introduce today is about how I want to answer some more fundamental questions of this process itself. And as a lot of pavilion projects are criticized for their structural purity, I would like to seek for architectural applicabilities of our structure first. So start by thinking about straightforward architectural problems, such as enclosure, glazing, MEP, insulation, and so on. And also we started to test out architectural programs to seek for creative spatial typologies. And most recently, I got a chance to build a mock-up structure of this in the context of SciArc Gallery exhibition. And my practice in collaboration with Igor Pantic, we sketched out a housing proposal to test out this idea. And this is currently under construction in SciArc parking lot. And we have been also trying to improve the assembly efficiency to produce and assemble most of the parts offsite. And here are some sneak peek of the current progress. It's going to be finished by the end of July. And some production time lapse, and some detail and some rendered vision of this project. And of course, going further, I'm seeking for ways to introduce these devices in the future. And I will be questioning again how differently we can build. So on top of this, I will compare and analyze precisely what processes and workflows we can improve. And obviously, the instruments will be the assets of steam bending timber structure and the newly introduced wearables. A result of the research will be sets of new assets and pipelines that can be applied to other design and construction workflows other than steam bending. And finally, here is the bibliography I listed so far. And as a conclusion, I want to argue that humanity today learned that technologies are going towards not creating some kind of human-looking android to replace humans, but it is developed to augment and enhance ordinary human to become superhuman and to become cyborgs. And we as architects are responsible to use the technologies and creatively to make our build spaces more interesting. Thank you for listening. Thank you.
Thank you, Sumin. Any feedback from you?
Maybe firstly, you, I gave some comments. Yeah. Fantastic PhD thesis, PhD candidate research. I think Sumi is a good designer, and last year she actually won the award in Digital Futures Pavilion Award, and that is really successful. You presented some images. I think that's as a kind of formalism paradigm. It's really special. but which is based on kinds of new methodology, especially engage VR and deploy the VR machine and actually introduce them to the construction process, and which produce a really special pavilion, and which could be constructed precisely, accurately, and elegantly, and as a kind of new form. I think, and you want to actually, I find you want to theorize this kind of process, followed by Andy Clark's cyber theory, and probably I'm more interested in your future research. So this presentation is more like a bibliography research, and you're collecting a lot of different information. Actually, if you're familiar with some mechanical mechanical science research, actually they already have a lot of this kind of the cyber poesis in their research. Especially, we have some collaboration with the South Nanfang Keji Daxue, which is located in Shenzhen right now. They have some special engineers make a huge category of this kind of poesis in mechanical science discipline. But actually, I'm more interested in the collaboration between mechanical engineer and architects. From your perspective, I want to know the special scientific perspective which can introduce all this new technology into the fabrication architecture industry. So the first question goes to, right now it's just VR as kind of instruments which help you to accurately position the components in their location. And what's the future vision of your research? Are there any additional cyber process you want to introduce to the construction process? And second question goes to, you mentioned about the structure performance and also the installation, this kind of building technology issues, aspects in real architecture. So I just curious on this kind of new formalism, and which gave us a new folding, unfolding computational geometrical possibility for the future space. How to introduce this kind of a new form and find a kind of new building technology details to solving the problem. The building should be a building, and if based on this kind of cyber culture, if the future building could change their form or change their spatial initial logic as a new tectonic, cyber tectonic, probably. So is there any vision or any motivation you want to define at the very beginning of your research to define a new building system? I want to know, is there any thinking for you want to extendingly explain to us, introduce to us? So just two questions for you.
Yeah, thank you very much for the question. And I'll try to reflect on the two questions. So first one was about what's new after the use of augmentation, AR, right? So as I try to kind of clarify in my research proposal currently, I'm not only interested in augmented reality, I'm interested in how humans can be augmented with the help of devices and technologies. So I'm especially interested in wearables, and currently I kind of narrowed it down to look at exoskeletons that they are already designed and marketed for construction workers, but not many construction sites are utilize them, and not many of them are actually commercially available. So it's kind of a new market, a new kind of upcoming technology and devices that are going to occupy our construction sites in the very near future, from my perspective. So I'm really interested in looking at them and to kind of explore what kind of different materials and structures we can construct with the introduction of these kind of things. For example, when we first had commercialized AR glasses, what we did is, nowadays, I think everybody will use it in construction sites with very easily, a very predictable application of it is beam management. You can see the underlying pipes and all that, but still, my question is, you have this technology, but you are still designing ordinary or traditional or commercial kind of design, then it's not that interesting. And I think my contribution of this field, is to really think about different possibilities of the technologies, using the technologies to explore different spatial or structural possibilities or typologies. Yeah. So that's something I think I'm very excited to explore with upcoming new unexplored technique. So that's something the exoskeleton is something like caught up in my mind, and I'm really interested in like looking at, for example, wearing robots, exoskeletal robots. You can actually lift up really heavy stuff with just hand, and you can actually carve out probably a very heavy stone, or maybe you can do something really hot or dangerous that you couldn't have done before, but maybe you can design something or make something that we couldn't do it before. So I think it's some kind of like unknown field. I think it's very interesting. So I'm not a good engineer or mathematician. I think as a designer, we have our role to also suggest some kind of ways of using technologies to design or produce different construct and structural possibilities. And that will lead to different programs and ways of redesign spaces. And second question about the architectural performance, and I mentioned about some kind of window details and everything. Yes, I think at least what I wanted to prove is that the first pavilion we made has been a great test bed or like manifestos for this construction process. But many were asking how, and even myself have been asking myself how this can be scaled up. How can we actually enclose this? How can we inhabit it? So that's why the first question, even before talking about technology, that's like what I had to kind of try to answer in order to, for example, have another next project but that is not another sculpture. So that's why I had to go through this, but I'm not really trying to argue or kind of argue that like I'm good like MEP designers or electrician. I think there are so many architectural problems that I don't know well, but at least some kind of fundamental things that I wanted to at least prove and develop, and like in order to step up to next stage from a pure pavilion to a more architectural applicable thing that can convince other people to be able to actually build this into a real building. Thank you.
Marcel, do you want to go?
Yeah.
Thank you, Sumin, for your presentation. There is something. I have a question for you because to me, it seems to me that it's interesting how you very quickly, in your interest, you honed in on this idea of the exoskeleton. So I was very impressed by the fact that you kind of worked your way to, okay, I'm going to get to the exoskeleton, and that's what I'm interested in. And then there was this split, which I found very interesting, because then you had the split between your project, which is the project that you had done where you had approved a kind of an enhancement and what it could do to your design process and the design result. And then on the other hand, you have this fascination with this idea of wearables, right? And so my first point that I want to make is, to what extent do we as designers really ever build anymore? That's the first point. And so at a certain point, I had, so that kind of rupture that I saw in your presentation, which is here's the pavilion and then here's the wearable. I mean, I see Robert Downey Jones and I don't see him building the building. And so this is where I was thinking, well, is this really about the idea of exoskeleton as a paradigm that we now need to explore how the architectural design process actually works in industry? Because I don't believe you're simply interested in, forgive me, I don't know you, but I don't believe you're simply interested in improving workflow and sort of kind of like, you know, creating a much more efficient pipeline. If I look at the pavilion, I know that's not your only interest. And so my question to you is this idea of exoskeleton a bigger idea that you're trying to engage about the design process and how design and the implementation and fabrication actually are kind of structured currently? And then how this idea of exoskeleton, and I know you're interested in wearables, but how this idea of an exoskeleton might help you as a paradigm begin to kind of investigate that as part of your thesis.
Yeah, thank you very much. I think you don't know me, but you know me very well. Yeah, yes, I'm not interested in just improving anything or optimizing anything. Yes, this is more about exploring new potentials and possibilities in design and space structure. And I think what a lot of people are very good in answering much better than me how to improve things and optimizing. And AR has been very, very helpful in BIM management, and they improved a lot of time and all this. So I think the exoskeleton is this is a proof that I didn't present well, but the idea of the whole, like a bigger picture and an umbrella, is to talk about augmentation. So AR headsets is one of it. And the next augmentation, what I can just try out because it's available, is the exoskeleton suitcase. But what I wanted to say is that it's just a trajectory in a bigger interest. Yeah. And whatever is interest, because I'm not technician, I don't know how to develop all these tools, but if they are already commercialized and available, that I can buy it, then why don't I try to use it to do something more creative and interesting instead of using it as a problem solver for optimizing. So what I'm trying to argue is, like, we as designers or architects, we should start to more, which is everybody here in this panel, I think what we are doing is to really try to figure or find different creative ways of using available tools. And if we are much better in technologies, we hack into those tools and we try to improve it in order to also improve our creativity. So that's why there is a bigger kind of strands of technology is about augmentation and wearables, which is a relatively unexplored area in architectural design field. That's why I think it's as a bigger strand of kind of technological, let's say, catalog. I'm interested in that, and one of that was AR headsets to begin with. Yeah. And I want to argue that this steam bent timber was just, of course, one of the application of this to be more creative, and like at least we as a team with our friends and colleagues, we're a really talented team of people. We proved that yes, we can actually build something that we haven't seen before, and we are very excited. And because I have this experience with steam bending, that's why I want to test it in deeper to try to use exoskeleton. Then how can we design differently? So it's something that I want to ask, and this is also, it's just a beginning of the research, so it's a research proposal. So I'm really interested in exploring that. Maybe at the end of this research, maybe I at least prove that, oh, this kind of things, we use exoskeleton, something a little bit different we can make. If I can at least prove that, I will think it's a successful research trial. Yeah, but I think there is a much bigger umbrella of this topic. Yeah.
Maybe I can just add something here. I don't want to say too much because it means on the details that I direct. But I think what you've landed, I think, which is really a great coup. You've got a topic that no one's thought about, and it's such an important topic: the augmented architect. And the challenge, though, is that it could be too big. And Philip was saying that we actually don't do much theory. Philip, you might have got that impression from me, but actually most of the candidates on the DDES are, I mean, Theodorus and Wan Yu are software developers, or I mean, Philippe is a kind of like he's a designer, so it's not that at all. I mean, and I think there is a potential, obviously a potential in terms of augmentation, thinking about how AI becomes an extension and so on. So you could potentially go into the world of neuroscience and follow Andy Clark and so on and go down there. But that's not what Samin's doing. I mean, I would love to think about that myself, but that's not what Samin's doing. And really the challenge is how do you kind of keep it manageable within the structure of a doctoral presentation, especially as it has a design component and so on. So it's actually kind of interesting. I think we've had the last three projects have all kind of almost address the same challenge in a sense that how do you contain an architectural doctoral thesis, and the challenge actually is to acknowledge that we're not experts at anything. I mean, I once went to a PhD defense in Stockholm where the candidate had actually asked in an expert who was an engineer, an expert, a computational scientist, an expert from somewhere else, and actually, that wasn't really a problem because they knew far more, and they were saying, "But this is superficial from this point of view." And we have this kind of strange situation whereby we do everything, but we're not really an expert at anything, and that's the challenge in some ways. Trying to recognize and trying to address that within the scope of a doctoral thesis. But I think this has been a really interesting kind of like debate going on here. And obviously there are different approaches. Roland has a certain approach, Akamengas has a certain approach, and so on. And but within that, I think there's scope for variation within it. But for you, Samin, I think that you've got such a good topic. I just want you to get out there and write the book and do the AD and so on. But I mean, there are so many other aspects you could open up into, especially theoretical ones. But I don't think you should. I mean, I think to my mind, if you think about the plastic mind, the way that Andy Clark and David Chalmers have argued about it, it's not just simply we adapt to our tools. No, we start thinking through our tools and using it in a different way, and the different forms of practice will emerge out of it, out of the affordances of the tools. And I think that's the really exciting area potentially in the future. But don't go there. There's too much to cover already.
Very good. I really appreciate Sumi as a designer. I think she is a talent. just like Jaha is a good designer, but Jaha is not a PhD, and she never got a PhD. So it's a little bit dangerous if you want to contribute your talent into something you're not good at. So I just want to ask how to set up PhD and what kind of PhD study we should have. I think normally, globally, I think as a PhD researcher, on the one hand, it could be a theorist, a very theoretical researcher on your thesis. And on the other hand, you should be a very scientific research process to figure out what's your contribution to the discipline. So I just, because right now, to me, make a proposal of your PhD thesis, but I still can see a little bit dangerous if just talking about what's new in your thesis, because although it's new in architect discipline, but it's not new in mechanical engineering discipline. So the key point is not just design through a certain kind of tools that give a new possibility. But I really looking forward to see some like systematic thinking that based on this kind of tools can gives new possibility as a kind of a paradigm shift to the construction process of architecture. So I think PhD thesis normally is very rational. It's not like artistic creative process. You should analyze this kind of process in a theoretical or in a scientific way. So I think as a proposal, this is a great presentation, but as a PhD thesis, you should make some options. And if you want to make some very meaningful research process, you need some instrument. You need this kind of skeleton robotics, which can enhance your research. I think I just wonder if FIU can give you this kind of support. I think as a PhD program, normally why the university invests a lot to PhD programs, not just about professors and students, but also on this kind of environment, if we can produce to the research process. So I think I'm looking forward, so means future, because you're really talented as a designer. And also looking forward to see if you can integrate your talent, creative design skills with this kind of skeleton or extension of human bodies kind of tools, instruments can give you new possibility. So that should be really fixed to either theoretical or new thinking, new possibility, or should be really solid physically and produce a kind of a new contribution. So I wonder, but new is here.
Let me what I was saying before is, to my mind, there are three modalities. Okay, there are three modalities. One is the kind of scientific method kind of approach, which all scientists do, working in the lab and so on. And there's a way of thinking, a way of working, and a way of writing there. There's another one which is more theoretical one, and I can't imagine Gilles Deleuze ever trying to produce a thesis according to the scientific method. It just doesn't work, and it's a much more fluid and dynamic way of thinking. It's like how you write a book. It's exactly how I write in some ways. And then the third modality is the design one, and in some senses we're caught in between all of these three, and it's quite challenging. Try to imagine what they could be. There are many different ways. There are many ways to writing a thesis. There are many ways of designing a building. But then there's the other question, which is a very interesting one, because I think that Shun Liu had some really beautiful work. But I could see that, she's already a teacher. Really, I could see an amazing teacher, I'm sure. But the challenge is ultimately we do this degree increasingly, and in some countries you have to have a doctorate in order to become a professor. You do it as a qualification. Now, that could be a very, very tight and precise study, and sometimes it's best if it is that way. But then you have to teach everything, so it's a real challenge. To do a thesis to become a teacher is a very strange way of approaching things. So I think we're facing certain challenges, especially now that it's becoming increasingly important in some countries, and Australia as well, to have a doctorate before you can start teaching. And I think it's it's a special challenge for architects, and I think we have to try and work out ways of doing that. And we're still, I think it's new territory now. We haven't really established a culture of doctorates in architecture, primarily because it takes us as long to qualify as an architect as it takes people in other disciplines to get a doctorate. I mean, when I was a student at Cambridge, there were people with PhDs at the age of 23, and I was still finishing off my School of Architecture degrees. So, but it's great that we've got a forum here where we can exchange ideas and see these different approaches. And I don't think there's any one approach that works, but it's really a question of trying to find out what range of possibilities are out there. Maybe, Maribel, you'd like to sort of add a comment at the end, just to kind of. Thank you so much for your contribution today, Maribel.
Well, thank you so much for allowing me to be here. It's been a pleasure, and thank you to all the presenters. I hope I was able to, in some way, help. I mean, I just wanted to address a little bit what you just said, Neil. I mean, the conundrum I think that schools of architecture are, I presently am lecturing at Georgia Tech at the same time that I'm proceeding with, my doctoral research. It's very difficult to be balancing that sort of situation, but it's a situation that we find ourselves in as architects. Now, my fortunate thing is I have many years of experience in the professional scope, so that makes a difference. But at this point, I think that architecture schools really have the whole doctoral research. I'm looking at the chat here. What is the future of the doctorate in architecture? There's so many flavors of doctorate in architecture at this point that it's a very difficult thing to pinpoint as one solution. So, but thank you everybody for your wonderful presentations and for allowing me to be here.
No, I would just simply add to that. Actually, even as an individual. At some stage in my career, I'm licensed as an architect, but I decided I didn't have time to design buildings. But I really consciously kept going and teaching a design studio because I thought otherwise I would become remote from that. And you become in the world of theory. And that's the challenge. I mean, I think with Lars Spaybrook, you're very lucky because you've got someone who's a very, very good designer, also with a very sharp theoretical mind. So it's our conundrum. How do we're complete generalists. The story I like to tell is the one that was asked of Steve Jobs by, and I forget the name of it now, one of his technical geeks, Steve Wozniak, I think it was, and he said he went up to Bill Gates sorry, I'm blanking his name. And he said, "Well, what do you do? You don't write code. You don't. What do you do?" And he said, "Well, Steve Jobs said, well, I'm not the conductor of an orchestra. He doesn't play the violin or whatever, but he conducts it." And it seems to me that's exactly what we do as architects. We're kind of conductors in some way, and maybe one has to kind of imagine the possibility of how a doctorate could reflect that in some senses, which makes it very challenging.
Absolutely.
Anyway, we should maybe wrap up now. We've gone beyond our limit. Can I just thank everybody for putting this together and for Nick Bow for chairing the session? There's always a whole team behind this who are working. We don't see it. It's like an iceberg, right? 10% you see. So thank you so much for that. And we've got 2 more sessions tomorrow. Well, I say tomorrow. It's difficult to say this because actually in China it's going to be later today, but in the States it's going to be tomorrow. We've got 2 more sessions, and then we've got a 4th session coming along, which is going to be well. Anyway, it's going to go in the next few days. So please log on and follow this. And we do have the times right on the schedule on the website, but it's very confusing. So be careful to read it correctly. Thank you, Philip. It's great to.
Thank you.
Thank you.
Thank you,
everyone.
All the presenter. Thank me.
Thank you
Bye-bye.
for all the comments.
Bye.
Thank you.